Hey folks, I'm Trek. Let's learn calculus. Hey folks, Trek here. In this video we're going to go through some advanced examples of limits and show you some of the complications that can come up and some of the, really tricky problems that you might face. So let's just go ahead and jump into it. Our first problem that we're going to work through is okay, so you should see this and think, holy crap, what do I do? And that's natural. It looks pretty messy, but it has a secret to it that we're going to point out here. And so first off, it has a hole. If you plug in pi, you get 0 on the bottom. This is why we can't just plug in pi, because there's a hole in this function. So instead, we have to do algebra to try to work out the hole. We have to algebraically remove the hole. Note that this doesn't change the function at all. In fact, if we were to graph this, the first thing we would note is hole at x equals pi, and we would make sure that gets represented in the graph. But since we're only interested in the limit, we can go ahead and algebraically remove that. So let's get started. What you might not realize is that both of these sections are factorable. The top section can be factored into 2 times x minus pi times x plus 2 or minus 2 pi minus 2 pi. Yes, like that. And then the bottom can be factored into x minus pi times x plus pi. Alright, so right off the bat you should see that we can clear out these two. And that is actually going to remove our hole from our function. Once we remove that, we get limit as x approaches pi of 2 times x minus 2 pi over x plus pi. And that's safe. Our hole has been algebraically removed. We can plug in pi. So let's go ahead and do that. Let's evaluate our limit by plugging in pi. So we get 2 times pi minus 2 pi over pi plus pi. And that comes out to be 2 pi minus 4 pi over 2 pi, which is, let's write it down here, -1. There is our answer. That is the limit as x approaches pi of 2x squared minus 6x pi plus 4 pi squared over x squared minus pi squared. Alright, good job. Let's move on to the next one. Next one is the limit of x cubed over 2x cubed minus 100x squared as x approaches infinity. Now, I didn't mention infinity in the video that covers limits, and that's because it really isn't any different. It has one sort of a little trick to it that we'll talk about, but other than that, you do the exact same thing you would do in other sort of limit problems. Now, before we jump into it, let's make it clear that infinity is not a number. You can't do algebra on it. You can't do like 5 plus infinity. It's a concept, and it has no place in algebra, but we can talk about it in mathematics and even make conclusions based on that infinity, especially when we're talking about limits, which is what we're going to do here. So, here's the trick you do with limits regarding infinity. You divide everything by the largest power of x. So let me show you what I'm talking about here. Limit as x approaches infinity of 1 over 2 minus 100 over x. And we factored out x cubed over x cubed. So this will cancel. And this will be what we're left with. Now this is safe to plug in infinity. And basically how this is going to work is we're going to distribute our limit evaluation to each of the terms. So let me show you kind of what we're talking about here. So we're going to take the limit as x approaches infinity of 1 over the limit as x approaches infinity of 2 minus the limit as x approaches infinity of 100 over x. And you can do this. Limits can be distributed just like most linear operators. But now this is something we can pretty easily think about. So let's get started here. What is the limit of 1 as x approaches infinity? Well, 1 is not related or dependent on x in any way, so it shouldn't change. So we stay with 1 on the top. Same thing with 2. It just stays 2. Minus the limit as x approaches infinity of 100 over x. Well, what is 100 divided by an absurdly large number? As you might say, a number really close to 0, and that'd be right. But so, just like in the previous video where we talked about limits, if we view 100 divided by x as our function in question, then if we pick some x value, let's say it's 1,000, we note that that's 0.1. It's pretty close to 0. But if we pick 10,000, then it's even closer to 0. If we pick 100,000, it's even closer to 0. For each value we pick for x, it gets closer and closer to 0. And as we go to infinity, it obviously gets almost indistinguishable from 0. Just like we evaluated limits in when I was teaching you limits, this has a limit of 0 because that is what is approaching. All right, so and then now we just have a bunch of constants. That should be pretty easy to do. We come out with 1/2. And this is the answer. Simple enough, right? All right, let's jump into another example. This one is, we're going to do another infinity one. Limit of 2x plus 1 over the square root of x squared plus 3 as x approaches infinity. So this one doesn't have a hole. We could just plug in infinity, but like I mentioned earlier, infinity isn't a number. We can't really get any information from plugging in infinity here because we don't know what 2 times infinity plus 1 is. We can really only talk about it in terms of a limit. So what we have to do here is the same trick we did before, where we divide by the largest power of x. Though this one has a little gimmick that we're going to kind of pretend that this is actually just x, because we know that it's going to get square rooted at some point. So we're just only going to factor out an x. So let's go ahead and do that. The limit as x approaches infinity of 2 plus 1 over x divided by x squared plus 3, all of that over x. And we factored out an x and an x. The x's cancel. And what we're left with is this. Well, this denominator is still pretty crazy. We need to do a trick here as well. What we can say is that x is equal to the square root of x squared, which it is. And then once we do that, we can then plug it into our root function here. And it'll come out looking like this. 2 plus 1 over x divided by the square root of 1 plus 3 over x squared. Because we divided, this became an x squared and got put into the root, and then it was x squared divided by x squared plus 3 over x squared. This looks a little messy. Let me redo that. Alright, now we can put our limits in. So just like before, we're going to divide through our limit. We're going to put it on each term. So we got the limit. I'm just going to put quotes here so you know what I'm talking about. That's just x approaches infinity of 2 plus the limit of 1 over x divided by the limit of the square root of 1 plus the limit of 3 over x squared. Alright, these are 4 limits that we can evaluate. The limit of 2 as x approaches infinity is just 2, because it doesn't change with x at all. So we have 2, plus the limit of 1 over x, which as x approaches infinity, just like in the previous example, we get closer and closer to 0. So plus 0 over the square root of the limit of 1 as x approaches infinity is just 1, plus the limit of 3 over x squared, which as x approaches infinity, 3 over x squared just gets closer and closer to 0. So plus 0. So this bottom root is just going to become the square root of 1, which is just 1. And on the top we're going to get with 2. So I'm going to equals 2 over the square root of 1, which is just equal to 2. Alright, good job everyone. Those are all the examples I had planned for this video. In the next video, I actually have an additional bonus video for limits I want to talk about. I want to go through the trigonomic limits so that we can work with those in the future without you having to just know them by heart. I want to show you how and why they are what they are. Hey y'all, I want to thank you all for watching. If you enjoy my content and would like to see more, please like and subscribe. Today's shout-outs go to Simone Yurts, I think is how her last name is pronounced. But anyway, she is self-proclaimed inventor of shitty robots, and she is hilarious and great at humiliating herself on camera. She also loves physics and science and stuff like that too. So if you enjoy those things, be sure to give her a look. And then we have Vi Hart. If you haven't seen Vi Hart, ever before, then I would find that surprising, but I felt like referencing her today just because it seemed like a good day to do that. She makes funny and or revealing videos about math, I guess you'd call them. Anyway, they're all great and they are well worth the watch, so give them a try. And that's everything.